Pop the cap. Alright, you've heard about SpudCell, the synthetic route that can eat, grow, and divide. But here's the thing, it's not alive. It's fragile. It needs to be spoon-fed. It stops dividing after 5 generations. So why should you care? Because this wimpy little blob is the foundation for something massive. I mean, I spent hours staring at my fridge, and now scientists have built a cell that basically does the same thing, but with way bigger implications. Let's get into it. First up, medicine. SpudCell's modular genome, split across 7 DNA plasmids, allows the team to program various functions of the cell independently. That's a game changer for drug delivery. Imagine a synthetic cell programmed to release a drug only when it detects a specific trigger, like the presence of a tumor or a harmful bacteria. That's targeted treatment at the cellular level. No more chemotherapy after side effects, just precision. Or think about insulin production. Right now, we use modified bacteria, but synthetic cells could be designed to produce it more efficiently, and they could be programmed to respond to your body's real-time needs. The researcher says this technology could help build highly precise therapeutic molecules like those created through amino acid-directed evolution. That's next-level medicine. Beyond medicine, SpudCell could revolutionize how we make things. The team believes artificial cells could serve as micro-biofactories that produce living substances. But the long term, SpudCell could be applied in diverse fields including pharmaceuticals, new materials, food, and carbon removal technologies. Imagine cells that can capture carbon from the atmosphere, or cells that produce biodegradable plastics, or cells that create new types of food. Kate Adamawa, the project lead, says, "We aim to manufacture materials in ways that put less strain on the earth. It's about using atoms in a more sustainable and distributed way." So instead of relying on fossil fuels and intensive manufacturing, we could grow the things we need. That's huge. Then there's the environment. SpudCell could be designed to detect and clean up environmental hazards. Synthetic cells could be engineered to absorb pollutants, break down plastics, or even detect toxins in the water. And because SpudCell can undergo selection and competition, we could evolve cells that are better at specific tasks. That's evolution in a test tube, and we get to choose the direction. The potential is massive, but we're not there yet. SpudCell is a proof of concept, a chassis, a starting point. And here's the coolest part. The team is making it open source. They've launched Biotic, a public benefit research organization that aims to build shared technical infrastructure for synthetic cell engineering. The goal is to keep it open for researchers around the world, so not a single corporation can monopolize the technology. That's how you accelerate progress. That's how you change the world. So, SpudCell is fragile, wimpy. It can barely do anything without help, but it's a start. That's today's Mirka Fact. If you made it this far, drop a test tube in the comments. Follow up backups for more science you didn't ask for.